Hello everybody. In this video we're going to be developing a short-run macroeconomic model that's based in a spreadsheet. In this video we're going to be combining three relationships, namely the IS curve, the real Taylor or RT curve, and the Phillips curve into a single model. We're going to start off with a brief review of each of them. If you need more background on these relationships, the website has some videos that discuss each of them in greater detail. And if you really want to dig deeper, I recommend having a look at several chapters in my book. So let's start with the IS curve. The IS curve shows us how the real interest rate affects the output gap through its impacts on aggregate demand. When the real interest rate falls, households and firms spend more, an increase in the output gap. When the real interest rate rises, households and firms spend less, a decrease in the output gap. If we have the output gap on the horizontal axis and the real interest rate on the vertical axis, we'll see therefore that the IS curve slopes downwards. Now the RT curve, or real Taylor curve, reflects the central bank's dual goals to stabilize both prices and output. Put differently, the curve shows us what the central bank will do if it stays on its policy rule, what we sometimes call a Taylor rule. If we have an increase in the output gap that reflects an increase in aggregate demand, the central bank must raise interest rates. Here, its goal is to keep demand and inflation from rising too much, and this is consistent with its broader goals of output and price stabilization. In the other direction, if we have a decrease in the output gap that reflects a fall in aggregate demand, the central bank must reduce interest rates. Here, its goal is to keep demand and inflation from falling too much, again, consistent with its broader mandate of stabilizing prices and output. Once again, if we have the output gap on the horizontal axis and the real interest rate on the vertical axis, the RT curve will slope upward. The Phillips curve, or PC, shows us the relationship between the output gap and the inflation rate. Suppose that demand increases and the output gap rises. Firms will face higher production costs. That includes higher wages, and these higher wages will be passed on to final purchasers of goods and services in the form of higher prices, that is, more inflation. In the other direction, suppose that demand decreases and the output gap falls. Firms will enjoy lower production costs, including lower wages, and these cost savings will be passed on to final purchases of goods and services in the forms of lower prices, less inflation. For this reason, when we have an output gap on the horizontal axis and the inflation rate on the vertical axis, the Phillips curve, or PC, will slope upward. An economy contains many simultaneous relationships among economic variables. These are relationships that happen all at once. Sometimes the relationships between these variables can be in more than one direction. Let's review some simple examples. We've already learned that the interest rate affects the output gap. When interest rates fall, it's cheaper for households and firms to borrow. Lower interest rates thus encourage more demand. This helps to bring the output gap up. In the other direction, when interest rates rise, it's more expensive for households and firms to borrow. Lower interest rates thus squeeze out some demand. This helps to bring the output gap down. That's the message of the IS curve. We've also learned about the relationship between output gap and prices. More demand will push prices upward. Higher inflation. A fall in demand will typically mean lower inflation. This is one of the main messages of the Phillips curve. However, both the output gap and the inflation rate will have impacts on the interest rate that the central bank sets in its efforts to achieve its goals of price and output stabilization. It will raise interest rates if the inflation rate rises above the desired rate of inflation, what we call the central bank's inflation target. It will reduce interest rates if the inflation rate falls below that target rate. In the same vein, if the output gap rises, the central bank will also be raising interest rates, once again in order to pursue its dual mandate of price and output stabilization. In the other direction, if the output gap falls, the central bank will be reducing interest rates in pursuit of its dual mandate. Our job now is to combine all of these simultaneous relationships into a single model. That way, we can see more clearly how everything happens at once. So let's look at an initial situation, what we will call our baseline scenario. We'll assume that all variables are at their long-run normal values. There are no extraordinary economic events, what we call shocks, in the baseline scenario. Demand and supply are both at their normal long-run levels. The public's expectation of inflation is exactly equal to the inflation rate that we observe, and that's exactly equal to the central bank's target or desired inflation rate. For this reason, the central bank will set the real interest rate at its long-run normal or natural level. In the upper chart, we see that economic equilibrium occurs where the IS and RT curves intersect. The output gap is at zero. Output is at its potential level with the real interest rate at its natural level. In the lower chart, we see that the inflation rate corresponds to a zero output gap, assuming that there are no extraordinary economic events or shocks. Now we're going to move to the spreadsheet-based model. The model will tell us what will happen to three key variables: the output gap, the real interest rate, and the inflation rate when certain economic events that are in some sense extraordinary take place. We call these economic shocks. Let's start by reviewing the layout of the sheet. In the upper left, we'll be putting certain shocks: aggregate demand, aggregate supply, inflation expectations, and the discretionary monetary policy of the central bank. In this simple model, we'll just be putting a plus or a minus, a plus for a positive shock, a minus for a negative shock. Directly below, we're going to be seeing a verbal explanation of what each of these shocks mean, but the end goal of this exercise is to find out the result of these shocks. We'll see these results in two ways. Here in the bottom left, we'll see a description of the shock's results, and over here to the right, we'll see graphical depictions of these shocks through shifts in the IS curve, the RT curve, and the Phillips curve. So let's do our first set of experiments.